Hi there everyone. In this video we're going to look at the electrophilic substitution mechanism for the sulfonation of benzene. Now I've written the overall equation at the top. We've got benzene reacting with sulfuric acid to give benzene sulfonic acid and water. Now the electrophile for this reaction is sulfur trioxide, and that can be produced in one of two ways depending on which acid you use for this reaction. If you use concentrated sulfuric acid, it already contains a little bit of sulfur trioxide due to some dissociation of the acid. Whereas if you use fuming sulfuric acid, which has the formula H2S2O7, it can be thought of as a solution of sulfur trioxide in sulfuric acid. As for the reaction conditions, there are two ways of sulfonating benzene. The first is that we can heat benzene under reflux conditions for several hours with concentrated sulfuric acid. Alternatively, we could reflux benzene at 40 degrees, so we're just heating it a little bit, we're just warming it, for 20 to 30 minutes with fuming sulfuric acid. Now let's look at the mechanism, and let's start by looking at the electrophile, which is SO3. Now these three oxygens attached to the sulfur are a lot more electronegative, so a lot more electron pulling than the sulfur. This leaves the sulfur atom with a very slight positive charge, and that means it's able to attack this benzene ring. So what happens is two electrons from the delocalized ring of benzene form a bond with the sulfur. And to make room for the formation of this new bond to the sulfur, this causes one of the sulfur-oxygen double bonds to break and become a sulfur-oxygen single bond. And that leaves a negative charge on one of the oxygens. Now we end up with a positive intermediate and this partially broken ring system again, and that's because two electrons from the ring have gone to form a bond with the sulfur here, and that breaks the ring. This next part here is quite different to the other electrophilic substitution mechanisms of benzene. So this hydrogen atom on the ring is removed by a lone pair, so a non-bonding pair of electrons from one of the oxygen atoms, the one closest to the hydrogen, on the sulfur trioxide that's already bonded to the ring. So when this oxygen picks up the hydrogen, that causes the carbon-hydrogen bond to break, and the electrons from that bond, the two electrons from that carbon-hydrogen bond, move back to reform the ring, which neutralizes the positive charge and reforms the delocalized ring.